Python has full support for inheritance, which allows you to specialize methods by overriding virtual methods. But how does that work in Python? You will learn that and the difference between dynamically typed and statically typed languages when working with inheritance in Python. Would you like to do a fun experiment? Open a new browser tab and search for "What is inheritance?" You will find many answers and many discussions. Some people love inheritance, some people hate it. Developers often not even seem to agree on why to use it. I think that the reason for this is that the goal of using inheritance is not the same in every programming language. Generally, I can argue that inheritance has two important goals: allow polymorphism and prevent duplicate code when using polymorphism. This sounds great, but it has one problem. It's not true in Python. Problem is with the first statement. Inheritance is needed to achieve polymorphism in statically typed languages like C# and Java. But Python is a dynamically typed language. Technically, you do not need inheritance to achieve polymorphism in Python. So, inheritance is not needed in Python to achieve polymorphism. But it still plays a role when using polymorphism. Let me show you a typical example. Here is class employee. It takes and stores name and salary and has method getInfo that returns employee information. I create a list of employees. I iterate the employee list and print the employee info. And here is the result. Notice that each employee is shown as employee. The text employee comes from the getInfo method in the employee class. But in this company, Vera is the manager and Chuck and Dave are programmers. The employee class is very generic and the same for all employees. Now, if I would ask you to make the output like this, you can probably come up with a couple of solutions to make the getInfo method show something different for each employee type. But there is one condition. No if-else statements are allowed in the code, and I'll tell you later why this is important. So what I will do is create an entire new class just for managers. I substitute one of the employee instances with a manager instance. And here is the result. The output shows managers and employees without the need for if-else. Both classes have method getInfo, but their implementations are different. This is the key to polymorphism, and you will see more polymorphism later. All you need to know for now is that polymorphism was achieved without the need for inheritance. But inheritance can improve this program, and you have probably already spotted a problem. Both the employee and manager class have the same class constructor. By duplicating the employee class, I created duplicate code. And this is where inheritance can help to improve this program. Inheritance prevents duplicate code. I recreate the manager class. This time it is empty. I have deleted the rest of the code. Notice the round brackets with employee in it. This is how class manager inherits from class employee. I create an instance of employee and manager and inspect both objects. I execute the code. Look at the result. Here are the attributes of the employee class. And these are the manager class attributes. As you can see, although class employee and class manager are of different types, they have the same attributes. And that is what inheritance does. The subclass inherits everything from the base class. This diagram shows an inheritance relationship between the employee class and manager class. In this course, I will call the top class the base class and the bottom class the subclass. The subclass inherits from the base class. By subclassing the manager, I created a problem, however. I create the employee list again. I execute the code. Look at the result. Manager Vera is displayed as employee. Class Manager inherits the class initializer and the getInfo method from class employee. The goal was to let them share the class initializer. Shared code between inherited classes is called generalized code. But now the getInfo method is also shared between the classes. Since the getInfo method implementation should be different in both classes, it needs to be specialized in the manager class. This can be done by overriding the method. All is needed to override a method is to create a method with the same name in the subclass. Notice that the getInfo methods in both classes return a different employee type. I execute the code. And look at the result. By overriding the getInfo method for managers, the behavior when employee objects are printed is changed. Overridden methods that change behavior are the key to polymorphism, and you will see this technique many times during this course. So, getInfo from class manager overrides getInfo from class employee. Methods that can be overridden must be virtual or abstract. In typed languages like C# or Java, you have to mark them explicitly with the virtual or abstract keywords. In Python, every method in a class is virtual, so every method is overridable by its subclass by default. How is this all displayed in UML? Here is the full class diagram. Notice that Class Manager only shows the overridden method getInfo. I would like to remind you that UML has many versions and you might have seen alternative ways to mark overridden methods. In this course, I chose to omit inherited attributes in the subclass and only to show specialized attributes like getInfo. So, what about adding a second subclass? In UML it looks like this. Can you make the programmer class in Python? Read the instructions, pause the video and resume when you're done. And here is the solution. You have specialized the getInfo method for class manager and class programmer and used instances of them in the employee list. And that raises an interesting question. Where is the employee class instantiated? The answer is, it is not anymore. The employee class is only used to inherit from. That makes one method in this code obsolete. Can you spot it? It is the getInfo method in the employee class. I delete it and execute the program. The program still works. You have seen a chapter from my Advanced OOP with Python course on Udemy. If you liked it, you can support me by enrolling in the course. I'll put a link with a discount in the description. And that's all for this video. Thanks for watching.